In this video, we are going to see how we can do PCA in Matlab. Now, PCA is used in PCA or principal component analysis is used in reducing the dimensionality of data sets while preserving crucial information. So it's a very important application in data analysis. Imagine you have a large data set with many features like measurements of different aspects of an object. Analyzing all these features all at the same time can be very complex and computationally expensive. So PCA helps you find a smaller set of features called principal components that capture most of the important information in the original data. So let's see how we can do PCA in steps in MATLAB. So the first step is to generate the data or to import it. So let me create a data set using the rand function. So this is my sample data. Now the second step is to create the covariance matrix of this data we have just created. So for that, I'm using the COV function. So COV of data returns the covariance matrix of the data generated. Now, if you want to find the sample covariance, we just need to add a 1 to the input arguments of the function. Now, if you are okay with the population covariance, there is no need for adding a 1 here. So we have generated our data and this is our covariance matrix C. Now, the next step is to find the principal components, the principal direction and the principal components. So for that, I need the eigenvalues and eigenvectors of the covariance matrix we have generated. So I go C, then so okay. So this is our eigenvectors and these are our eigenvalues. So you can see the eigenvalues along the diagonals of this matrix and this is our eigenvector corresponding to these eigenvalues. Now we need to find the prominent eigenvalue and the corresponding eigenvector. So for that I am using the max function. So Emax comma ind is equal to max diag e. So diag diag e function this creates a vector of diagonal elements in this matrix E. Then max of diag E gives us the maximum value in this vector, the greatest value in this vector, and the extra argument I and D stores the position or the index of this vector or of this value inside the vector. Now we can store this, we can store the principal direction, which is the vector which is which corresponds to the largest eigenvalue, which is this vector over here, this column vector over here, so v comma 1, or for a more in a more general fashion we can write colon comma ind. So v of colon comma ind, so this gives us the principal direction, the first principal direction, or the prominent principal direction. So here we have Emacs and IND. So let me just make it. And this is our prominent principal direction, the second column vector over here. Now we need to transform our data to 1D data. So for that, we multiply data with the original data with the principal direction. So, and we get the principal components. Fourth principal component. So the principal component is equal to data times PD1. So this is our principal component. Now we can decode the data back if we want. So if I type PC times PC times PD1 star, I have decoded my I had tried to decode my original data back. Now let's um, plot. So let's save this. So decode data. PC times PD 1. Now let's try to plot the results. So for plotting the results, let me open a figure. So I am using the scatter function here. So scatter data 1 and data 4. Did I make a mistake here? Scatter data. Oh, there should have been a semicolon. So yeah. Now let's hold on to the figure. Then scatter y 1 and y char comma 2 colon comma 2. So when I run this, I get so yeah, when I run this scattered points belong to the original data, and this line which is formed here by these points, this is the reduced form of this 2D data which is spread over this plane. So PCA helps us in reduction of data from higher dimensions to very low dimensions. So this is how we do PCA in MATLAB. In the next video, we might probably be looking at linear regression using MATLAB. Thanks for watching.